Now, carrying on with the discussion of f is inversely proportional to r, I wrote f is inversely proportional to r square. I wrote f is inversely proportional tional to inversely proportional to r square. I could have written f is directly proportional to 1 by r square. Now if I try to see, if I do one change here in this figure, if I do one change in this figure, see what happens. If I write like this, if I draw the graph, if I plot f versus 1 upon r square, I'll get a straight line, because now it is directly proportional to 1 upon r square. I'll get a straight line. Now this was an interesting fact. I purposefully did this. I took this example of inverse square law. I took this example of inverse square law to make you understand what is the implication of this, why we are doing graphs, so that we know what graph, what type of a relation will give what type of a graph, so that we know this is the y-axis. Let me write it correctly. Yes, this is the y-axis. The reason for understanding this graph is that at least we know how the function behaves in a certain, I mean, in the certain domain and range, a certain domain, and what would be its range. Let us say I want to know whether this limit, this x square has any limit in 0. So of course it does. It is going this side to minus infinity, and this is going to plus infinity, and this is going to plus infinity. So yes, here the limit at x tending to 0 is infinity. See, let me repeat. If I take this graph x square and I want to find the limit exactly at this point, I want to find the point at exactly at this point 0. I want to find at 0. So if I see the right side of 0, this is the right side of 0 and this is the left side of 0. On the both side, I'm seeing the function is going towards infinity. Both sides. So the limit of this function at 1 upon x square will be infinity. This is what that's the main purpose of studying graphs, because at least I know, have an idea about how the function works, so that I can guess the limit easily. I can guess the limit easily. Okay. Now let's carry on with our discussion further. This was just a minute. This was number 6. We are now going for seventh graph. We are going for the seventh graph. This is our seventh graph. This is sorry. This is our seventh graph, and this is we now take the general case when fx is equal to 1 upon x 2 to the power of n minus 1, that is odd. Like you will get when n equal to 1, you will get y equal to 1 upon x 2 minus 1, and you will get 1 upon x. N equal to 2, you will get 1 upon x 1 upon x. 2 into 2, that is 4 minus 1, and that is 1 upon x to the power of 4 minus 1, that is equal to 1 upon x cube, the graph we saw just now. N equal to 3, I'm now writing directly, this is 6 minus 1, 1 upon x to the power of 5, and so on and so forth, odd powers. Now the graph is going to be like this. This is your x, this is your y-axis, and we saw this type of a graph like this in 1 upon x cube. We saw this graph of 1 upon x cube. Let me draw the graph of 1 upon x cube. 1 upon x. First I'll draw the graph of 1 upon x. 1 upon x graph was something like this. 1 upon x. This is the 1 upon x graph. See, this is the 1 upon x graph. This is 1 upon x in white color. In the blue color, I'll show you 1 upon x cube. Now see, this will start from here. It will go a little down, and this is the blue color is 1 upon x cube. 1 upon x cube. In similarly, this will go a little here. Sorry, I made a little mistake in drawing this blue color graph. Wait. Now this will go like this. This will go like this. It will touch this place and it come down here. It will come down here. This is the blue color graph is 1 upon x cube. And similarly, if you see this 1 upon x5, let me take yellow color graph. 1 upon x5, let me say it will come more like this. This is 1 upon x5 is the yellow color graph, and it will come like this, turn this way and this way. This is the yellow color graph for 1 upon x to the power of 5. Now you have an idea how to draw this graph and how they will behave. Now the next one is the eighth one. This is for odd powers. This is for odd powers. Now for even powers, we will now see, okay, first of the range would be same. The range would be same as we just saw here. See, the range would be as you saw in x 1 upon x. What was the range in 1 upon x? Let's see. Let's see the range in 1 upon x. Let's see the range in 1 upon x. Yes, I think this is x square. Did I draw 1 upon x? Did I draw 1 upon x? Yes, I have drawn. Let me check. Where is it 1 upon x? Just a minute. I will show you so that you don't have to see. This is 1 upon, no, this is not 1 upon x. I didn't draw 1 upon x. I have a doubt. X cube I have drawn, x to the power of n I have drawn, 1 upon x. Yes, here it is. This is the 1 upon x. Did you see the domain? And did you see the range? The same will be copied. The same will be copied to this one. Let me come down and show you this here. Here the domain and range would remain the same. Here the domain and range would remain the same, right? And now we will go to the graph number 8. Graph number 8 is, wait, yeah, no problem. Let me do with this line only. The graph number 8, the graph number 8 is fx is equal to 1, 2 to the power of x, sorry. This is x to the power of 2 to the power of n, all even powers, x square type graph. I'm talking about x square type graph. Now see, we have already drawn 1 upon x square. When n is 1, we have y equal to, this is y equal to 1 upon x square. N equal to 2, we have y equal to 1 upon x4 and so on. So x6, n equal to 3 will give me x6. Y equal to 1 upon x6. The graph of your 1 upon x square you have seen. 1 upon x square is something like this you have seen. 1 upon x square graph. This is the 1 upon x square graph. This is the 1 upon x square graph. Now if I draw with some color, for this is okay. First let me write, this is the white color is for 1 upon x square. 1 upon x square is for the white color. Now for the yellow, I will draw for x to the power of 4. X to the power of 4 will be something like this. See the yellow color. Yellow color. Can you see the yellow color coming down? It will be 1 upon x to the power of 4 graph. Wait, let me write it somewhere here on this side only. 1 upon x to the power of 4 graph will behave like this. So see, in the lower part, it will come more closer to the x-axis. This is your x-axis. This is your x-axis, and this is your y-axis. So this is the way, and domain and range remains the same as that of x square. It doesn't make any change. Let me just copy that from there. Domain and range, where did I write here? Did I write the domain and range? Yes, I wrote the domain and range. Here, I just need to copy this line. Wait a minute, just need to copy this little line. So that, yes, if I copy this and I paste it there, and the same, domain range remains the same. Let me paste it. Yes, the domain range remains the same. Let me put it somewhere here. Yes, and now let me make the things. Okay, let me rub this and let me put the line. Domain range remains the same. Nothing changes. Nothing changes. So now with this, you have some idea how this graphs behave. You will also have an idea. Wait a minute. You also have an idea. Wait, uh, uh, let me take this whole thing that side. Wait a minute. Wait a minute. Let me take this whole thing little bit that side. Wait. Let me take it this side. Wait. Yes. Just a minute. Let me take it this side. Let me rub this, and yes, and let me put this together. This is the open interval. So now we will go to the ninth graph. The ninth graph. We will go to the ninth graph. Let me see whether I have marked. Yes, we will see. Yes, just a minute. We will see the next graph. We will see the next graph. That is the ninth graph. The ninth graph is something little interesting. See, this is the square root graph. Ninth one is a square root. Your fx is x to the power of 1 by 2. That is nothing but you know this as this one. This is your this. Now, this type of a graph, at 0 it will be 0, undoubtedly. At 1 it will be 1. So, if I draw the graph for under root of x, under root of x. This is your 0. At 0 it will be 0. At 1 it will be 1. And after that it will start coming down like this. This is your y equal. This is under root of x graph. This is under root of x graph. This is your y axis. This is your x axis. You can draw this that way only, the way I drew. X and y, you take points. At 0, you get 0. At 1, you get 1. You cannot put minus 1. Remember, under root of minus 1 will be iota. Don't put minus 1. Minus 1 is not allowed. Take 2, it will be under root 2. Take 3, it will rise slowly. Wait, I made a little mistake here. Wait, let me draw it this way. This way it will go. This way it will go. This is your under root. This is your point 1 comma 1, 1 comma 1. So this is the way you will have to do it. Fine, the plotting. Now you can guess the range. You can guess the domain also. You cannot take negative numbers for x. You cannot take negative numbers for x. So your domain is your domain. Domain is your r plus union 0, which you can also write as 0. You can take 0 here. The 0 is allowed. So this will be a closed interval union infinity. This will be like this. So now this is the domain. Now what is the range? Range is also the same. The range will also, because no part of the graph is here. Graph का कोई भी part यहाँ पे नहीं है. The whole part is on this quadrant. The whole part is in the first quadrant, and first quadrant all are positive. X is y. So your range is r plus union 0, that is same as closed interval 0 and infinity. This is semi-closed rather, not closed interval, semi-closed. Closed on the 0 side and open on the infinity side. Now with 1 upon x square, let us now see 1 upon x cube. This also we need to see. This is the next graph. That is your graph number 10. This is graph number 10. Y is equal to fx to the power of fx equal to function of x is 1 to the power of 3. That is the cube root. You people know how to write this one. Like this, cube root. So the graph of this would be like this. Now you see. The graph would be like this. Just the opposite way of your doing. See, now you did this for your x cube. Na? You did this for x cube. You did this for x cube. I'll now show you what you will do for this. You will do this. Now you see what happens. This will come like this, and this will go like this. This is 1 upon x cube. I drew this white one for you to may understand how the thing is behaving in both of the cases. The white color is for the white color is for x cube. The white color is for x cube, and the yellow color is for 1 upon x cube. Sorry, under root x cube. Sorry, not under root x cube, it is cube root. I made a mistake. Sorry. This is x to the power of 1 upon 3, or you can say cube root of x. Cube root of x. Now it's okay. Now you have been able to compare. Now you see in this, the domain is R as well as the range is R, because they are going both on the x-axis, they are going both on the y-axis, both sides. This side also, this side also. So your range, sorry, first let's write down the domain. The domain is simple R. That means you can also write minus infinity. Sorry, let me write it here. Yes, you can write this as same as minus infinity to plus infinity, or you just write this one and the same thing. And in range also the same situation. Range you can write R this way, or you can write this minus infinity to plus infinity, and this is your domain and range of this graph. Now we see you have understood this cube root, you have understood this square root. Now I will tell you if the powers are increased. If the powers are increased, how will it behave? Now let's do this. I think this is the 10th one. Wait a minute. Let me check if it is the 10th one. It is the 10th. Now we will do the 11th one. We'll do the 11th one. That is, we will do the 11th one. 11th one. Oh, sorry. This is the 11th one. This is the 11th one. And we are doing y equal to fx equal to x to the power of 1 upon 2n. When n is 1, we will get y equal to x to the power of half, under root x basically. N equal to 2, you will get y equal to x to the power of 1 upon 4, and so on and so forth. Now I'll draw this graph for you. Now you see how this graph happens. Now this is your x-axis, this is your y-axis. You drew the graph of under root of x like this. That is, this is under root of x. This is x fourth power, 1 by 4th. This is of x square. Now this is the point 1, 1. This is the point 1, 1. Coordinate 1, 1, 1 coordinate and 1 coordinate here. This is the point 0, comma 0. This satisfies. Now see how will I do this for, see, this curve will be, this curve will be something like this. You will draw it. My drawing is little bad, can't help it. It will come little down like this. This is x fourth. This is the way it will behave. It will come little down, shift towards the x-axis. Now I want to draw for x to the power of 1 upon 6. So that will be something, let me take this color. Maybe it will go like this. It will not touch the x-axis. Wait a minute, wait a minute, wait a minute. I made a mistake, wait. It will be something like this and it will come more like this. Wait a minute, again the drawing is bad. Let me write this under root of x to the power of 1 by 4 here only. Wait, x to the power of 1 by 4. Let me write it, x to the power of 1 by 4. 1 by 4. And now I'll draw for the blue one. I'll draw for x to the power of 1 by 6. Let me draw this and this. This is x to the power of 1 by 6. That is equal to under root of x 6 here. I hope you understood this. Now the domain and range remains the same. There is no change in the domain and range of this under root of x. What was the domain and range for under root of x? Just under root of x, just copy it from there. See what is the domain for under root of x. This is the domain and range. Just copy them. Nothing else you have to do. Just copy them and paste it here. Wait. Just paste it here. Paste it here and I will see what changes can I make. Wait. Yes. Wait. Yes. Now I will show you. See. Yes. Let me rewrite this properly. This is R plus union 0. And this is, just a minute. This is 0, comma. Let me rub all this stuff. 0, comma, infinity. And the range is your, again the same thing.